So we're going to go over evaluating powers, okay? And what we have here is an exponent. That's an exponent question. And we just got to go over a couple definitions. First of all, the number, or the larger number, is the number 2. Do you happen to know what that's called?
2 is the base.
That's right. So this here is considered the base of an exponent. And what is the number 5 considered?
The power or exponent?
Yeah, the power or the exponent itself. Right? So this would be the power or exponent. Well, exponent's usually the whole thing, but whatever, it's fine. Exponent. Okay, so we have this information. How does the power or the exponent affect the base? What would the equivalent of this be written out in a longer form?
Since it's 2 to the power of 5, it would be 2 times 2 times 2 times 2
That's
times
right.
2.
So what we're going to say is x. The unknown is equal to 2 to the power of 5. So x is equal to 2 times 2 times 2 times 2 times 2. How many times did you repeat that?
5 times.
That's right. 1, 2, 3, 4, 5. So in other words, when working with exponents, we repeat the base, the amount of times the power tells us to, and multiply it. So let's quickly do a little of this multiplication. What's 2 times 2?
4.
Okay, so that could go to the first guys, but we still got to multiply it how many more times?
3 more times.
Yeah. So let's do the next pairing. 4 times 2? 8. Next pairing?
16.
And then
the answer is 32.
that's right. So in other words, 2 to the power of 5 is equal to 32, right? So let's go through a couple examples here. Well, example 1, I'll get you to try to talk me through it here. Negative 3 to the power of 3 is equal to
Negative
what?
3 to the power of 3. So x is equal to negative 3 times negative 3.
That's right. Negative 3 times negative 3?
Negative 3 times negative 3 because it's 3 times.
Okay, so because it's 3 times, we repeat the base 3 different times. 1, 2, 3. Just like the exponent told us to. Now let's equate this. What is negative 3 times negative 3?
That would be positive 9.
Positive 9.
So
now we have positive 9 times negative 3.
Which is equal to negative 27.
That's right.
Therefore, x is equal to negative 27.
Exactly. And I'm going to write it like this. Negative 3 to the power of 3 is equal to negative 27, which is also equal to x. All of those things are equal. It's like writing a sentence in English. We just write it with symbols instead. Negative 3 to the power of 4. I don't want to do that one. If we had added negative 3 to the power of 4, okay, just as a side note, so we'll call this example 2, where can we really start off now that we have this information?
So since negative 27 is equal to negative 3 to the power of 3,
yeah.
Negative 3 to the power of 4 would just be negative 27 times negative 3.
That's right, times negative 3. And the reason being is because we already know that negative 3 times negative 3
is equal
exactly is the equivalent of negative 27. So we substitute those 3 in for negative 27, and then we do negative 7 times negative 3
is positive 81.
That's right. It ends up being a positive number, right? Yeah. Because negative times a negative is positive, exactly. So in this case, negative 3 over 4 is equal to positive 81. Great. Example 3. We got 2 over 3 to the power of 3 is equal to x. What is x equal to in the longer version of this?
X is equal to 2 over 3 to the power of 3.
Okay. And how do I write this out in the long form?
You'd have to make it into
I don't actually. I can keep it as a fraction. What's the base?
The base is 3.
Well, actually, the base is this entire term. It's 2 over 3.
Oh,
the fraction is the base.
Yeah.
And the exponent, or the power, is just 3.
3.
So normally, what do we do when we have our exponent base? We repeat what?
We repeated the number of times the exponent tells us to.
Yeah. So how many times does this tell us to repeat?
3 times.
So we go 1, 2, 3. And what are we repeating?
2 over 3 3 times, so you'd multiply 2 over 3 by 2 over 3 by 2 over 3.
That's right. Now we got to remember our fraction rules, and this is why I remember I told you our fraction rules come important. When I'm multiplying fractions, what do?
You multiply the numerators.
Yeah. So what are they?
The numerators are 2 and 2.
So what does that equal?
4.
Okay.
So it's 4 over 3, which is improper.
It's not over 3. But multiplying, we do the numerators by the numerators, and we multiply the denominators by the denominators. So what is 3 by 3?
9.
That's right. So 2 over 3 times 2 over 3 is 4 over 9. And we still have to multiply it by, whoops, that should be a 2 on top. 2 over 3 one more time. So what is this going to be equal to?
Now it's going to be equal to 8 over 27.
That's right. So it turns out that 2 over 3 to the power of 3 is equal to 8 over 27. Okay? So a little different. Now what we're going to do is we're going to, with those rules, let me just jump to a new page here. I'm going to give us a bit of a volume question. Volume of a cube. We know a cube is a three-dimensional square, right?
Yep.
Okay. And it just so happens volume is length times width times our height. Okay. So we have our cube here. Everything's the same length. Okay. So the volume of a cube is the volume is equal to
length.
This side times this side times this side. Now you're right. Normally we write length times width times height, right? But do I have to write them as different variables? Are they different in length if this is a cube? No, all of these sides are equal. So let's just represent them with one variable. Let's just call it S. So that means side times side times side. Well, can I simplify that even more?
3s.
3s, or this would be 3s.
S to the power of 3.
That's right. It wouldn't be 3s because that means 3 times it. That would be s to the power of 3. Now what if I told you that s was equal to 5? Okay? 5 centimeters to be exact. So this side is equal to 5 centimeters. I measured one side. Can I calculate the volume of this cube?
Yeah.
What do I do?
So since if the volume is equal to s to the power of 3, and s is equal to 5 centimeters, therefore the volume would be equal to 5 centimeters to the power of 3.
That's right. So we substituted. We substituted in for this s value. What did we put in place of that s?
5.
That's right. So the volume is equal to 5 to the power of 3. Now this is a tough one to do off the top of our head, so let's spread it out again. 5 by 5 by 5. Let's do the first pair.
25.
That's right. 25. And what else? If am I done? Anything else I got to do?
Yeah, 25 times 5, which is 120.
Excellent. And because this is in centimeters and it's volume,
it's centimeters cubed.
Excellent. Cubed. In other words, three-dimensional, right? And that makes sense because our power was cubed, right? So that's kind of a quick introduction to exponents. That's not what I wanted. There we go. A quick introduction to exponents, how to use the base and the powers to solve questions, and how to substitute in using exponents.